Hi, I'm going to demonstrate using InterFringe to process a 4-frame phase shifting interferogram. Alright, this first example consists of discrete images. There are 4 images, each corresponding to a different phase. These are separated by 1/4 wave, so altogether it's a 4-frame interferogram with pi/2 phase shift between images. The software puts these in an ascending file name order and assembles them in an array of frames that can be played like a video. So here we are. The first thing we need to do is create a boundary as usual, and we'll make sure that that boundary is accurate in centration and radius. This is a synthetic interferogram, so it's ideal in many ways. And it'll be phase shifting analysis. Now the first thing we need to do here is to set the density of points that we want to analyze. I'm going to set every point. It's possible to use a larger number here and speed up the processing. And that can be useful, especially when you're doing video analysis, but it's something that makes sense to check by increasing this number and seeing whether the resulting model is changed significantly. Okay, here are the points. We set them every pixel, so pretty dense. And we'll do 4-frame phase shifting analysis here. And here's the result. As you can see, we've got a surface that is a wavefront that is assembled from all the different phases. This is calculated modulo 2 pi and then stitched together as usual. And we can calculate standard Zernike coefficients from here. As you can see, we've got one wave of spherical aberration and one wave of fifth order astigmatism, and those were what we used to create the interferogram, so we're within 1% of the targets in both cases. It's very important for the phase shift to be accurately pi/2 in between frames for using 4-frame techniques. So if your interferometer is calibrated properly, that's fine. All right, and as usual, from here I can generate a report. And we'll just put a couple of things in here. I'm going to include the peak to valley error, and I'm going to put a radius of curvature in here. Again, this is something that the user has to supply. By looking at an interferogram, you really can't tell what the reference wave was like. And if you use a spherical wave as a reference, then that radius of curvature is impossible to determine from the interferogram. So you need to input that into this dialog in order to get it to be included in the report. As usual, I'm going to create a new folder for the report so that the image files that are going to be written in there don't stomp on any other image files, and also don't get lost outside of the folder. Alright, and as usual, we're going to leave it in docx format, and it's coming up in LibreOffice. So, there it is. There's a report. And it includes the elements that we asked for in the dialog, slide elaborations and Zernike coefficients, a plot, a copy of the plot, and a 3D model. All right, thank you very much. Let's go to the next example, a 4-frame. The alternative format for saving these is a video file with 4 frames in it, and that's what this is. As you can see, it's similar. It has a different composition, but everything behaves exactly the same once you open it up. The process of doing the analysis is exactly the same. Yeah, you see, it tells me I forgot to do something. And we're just going to use 2 as this density. That's 1/4 the number of points, so the processing is considerably faster, but for interferograms this size, it doesn't really matter. All right, here is the reconstructed wavefront. And this time I won't use those optional parameters. And there we are. There's the report. You can see that it's really, the process is really identical for the video file or the 4 frames. The only thing is the 4 frames are separated, are selected in the same dialog, in the same file selection dialog. All right, there you are. Thank you very much, and that concludes the 4-frame phase shifting analysis demonstration, and other features are demonstrated in other videos.